record on the computer. Okay, so we're recording now. And so you can still see my screen, right?
Yeah.
Okay.
Yeah.
So basically what this is a supply chain model, a simple supply chain model. And you can see I have customers here, and I have 3 distribution centers and 2 factories and 2 suppliers. And this is a really simple model where you only have a single product called A, raw A, material A, finished goods A. What's it called? Let's see, go to materials. It's called finished goods A, FGA. And it only has one raw material, raw A. And so what happens is customers demand, there's periodic demand from customers. So a customer places an order, and the order has the quantity that they want and a due date.
Okay.
And what we want to do is we want to fill the customer orders from the distribution centers. And then when the distribution centers need replenishment, they get replenished from the factory. The factory, when it needs to be replenished, it does manufacturing. When the raw materials for manufacturing need replenished, they are replenished from the supplier. So you're just backing up the replenishments.
Okay.
And so the particular aspect of the model that I want to talk about today, I'm going to talk about some interface here, is really just the customer and the distribution center question. So we're going to have periodic customer demands, and what we want to decide is where should those demands be satisfied from. So when customer order 1 places an order, for example, should we fill it from DC1 or DC2 or DC3? And when should we ship it? So we're given a due date, and we want to know where to fulfill the demand from, and when to ship it. Okay.
Yeah.
And so that's the basic thing that we're going to do. But what I want to be able to do is I want to be able to solve this problem, solve this assignment problem from an optimization from a Python script. So what I want to do is I want to record the state, in other words, the set of open orders and the inventories. And then I want to call this Python program, and I want it to be able to solve an optimization to make the decisions on where to ship from and when to ship it. Okay?
Yeah.
So let me show you some of the details on the data. It's a data generated model. And so we have auto create for the entire supply chain. We have the customers, the distribution centers, the factories, and the supplier. We have something called transportation lanes, which define a lane from one object to any other object. So like here's the transportation lanes from the distribution centers to the customers. So DC1 to customer 1, DC1 to customer 2, and so on. Associated with the transportation lane, you have a travel time, which is a random, it can be anyway, it's an expression, so it can be a random amount of time. And then I also have the expected travel time, because for our optimization, we need to be able to make decisions based on the expected travel time, not an individual observation of the travel time.
Yeah.
We have the materials, which I've already shown you, which is raw material and finished good A. We have a set of inventories. So I have inventory for finished goods at the 3 distribution centers and the 2 factories. For raw materials, I have at the 2 factories and the 2 suppliers. So that's the inventories that I have. Each inventory has an initial quantity. We have a Boolean where we can specify whether or not we should assume it's infinite. So in Simio, if you have an inventory and you assume that it has infinite inventory, it will just always meet demand. So in other words, if you try to consume from that inventory, even if the inventory is 0, it will fulfill that consume request, and the inventory level will just be negative. There's a review period, and I have these for continuous review. So every time a demand happens, you review the inventory. And I have a really simple single replenishment policy of reorder point, reorder quantity. So for each one of the inventories, I have its corresponding reorder point and reorder quantity. And then I have the replenishment process, or the process that gets triggered automatically by Simio when a replenishment event happens. And so you can see that I have inventory replenish for the distribution centers in the factory, and then I have manufacture batch for the finished goods at the two factories. So when I need to replenish that, the finished good inventory at the factories, then I call a different process because I want to actually manufacture the products.
Okay.
Then I have an inventory position, and you'll note this one is gray. The column is gray. So let me choose another column so you can actually see. You notice how this column is gray. In Simio, what that means is this is a state column, okay? Which means you can write the values. It's not just read, it's read write. Okay?
Yeah.
All right, so we have demand. And so this is an interesting model. I'm not sure you would have ever seen one like this, but the way the demands are created, we periodically create demands using a process. So there's a process that basically says every 24 hours for customer one, trigger a demand, and the demand is going to be for the quantity that's triangularly distributed. And this is the first arrival date, and we have infinite occurrences, and then we have an order lead time of 24 hours. So basically what this means is every 24 simulated hours, we're going to trigger a demand from customer one. For customer two, we're going to trigger a demand every 48 hours. For customer three, every 120 hours. For customer four, 72 hours. And for customer five, 24 hours. So this is just how we're creating the demand for customers.
Okay.
Okay. And then we also have replenishment sources. And so this tells us where we're eligible to replenish inventory from. So when I look at customer one, for example, like customer one can either be replenished from DC1, DC2, or DC3. Customer two is only DC2. Customer three, either DC2 or DC3. Customer four, DC3. Customer five, DC3. So it's letting me restrict the replenishment sources for basically any inventory in the system. And then we specify what transportation lane is used, and then we specify the inventory that we use. And I need that inventory specification so I can see if the inventory level is sufficient to meet the demand.
Okay.
Okay. Then I have the customer orders table, and you'll note these are all gray, so these are all output columns. So this is an output table, which means that it starts out empty when you start the run, and then rows get created. Okay? Does that make sense?
Yeah.
Okay. So, Grant, you with me? You get any questions from you? You've seen this before.
Yeah, I've seen this part before. I did notice you added the inventory to the distribution center table, though.
Yeah, the inventory position, you mean?
Yeah, the state column one.
Yeah.
Yeah.
Okay.
That's, I think, the only thing different from the model I have to this one.
Okay, so the focus of what I want to meet today, and the reason I want Jingwei here, is really not Jingwei to understand this model in particular, but to understand or to see how we interact with Python.
Yeah. Yeah.
And that's what I thought you might find interesting. So there are a couple things you have to do the interaction that I'm doing here. I'm using Microsoft SQL Server Express, which is free. So that's the database that I'm using. Okay, so you have to have that installed. You need to have the Odbc driver for Python, so Open Database Connectivity. I think that's what Odbc stands for. And depending how you're going to use this, you might or might not need Visual Studio, and you can just use Visual Studio Community Edition, which is, again, freely available. Okay, so I'm going to show you some of this stuff. I just wanted to list out what you need. Okay, so with SQL Server, there's a application that you can interact with it. It's called Microsoft SQL Server Management Studio. It's also freely available. And you can see that's what I'm looking at right here. And so here's my table. I have a database called Supply Chain Model. And in the share that I showed you, there is a backup file, the supply chain model.bak. And if you install SQL Server Express, and if you install the Management Studio, you can restore from backup, and you will have a copy of this database. And you can see that it pretty closely mimics the table structure that we saw in the Simio model. So you have customer orders, inventories, materials, objects, replenishment sources, and transportation lanes, same things that we saw there. We also have a table called open orders, which is the table that we're going to store the orders that haven't yet been filled. Okay.
Okay.
So I created that. I created this database. And also note that if you go back to my Simio model, some of these tables are bound to that database. So for like the objects table, it's bound to the database. So I could create the model from data in the database. Transportation lanes is bound to the database. Materials is bound to the database. Inventories, demand is not. Replenishment sources is bound. So all of these tables that are property tables are bound to the database. Customer orders is not, because we don't have a binding for an output table, so that's why it's not bound to the database.
Yeah.
Okay. All right. So you need that, and then I have a Python program, and so this is also on the team site. And so this Python program, there's a script called supply chain.py. And it's really simple. This doesn't do any optimization. It's Grant's job to come up with a nice optimization. I'm just showing it how to get it set up so that you can do the communication. And so you can see what happens is I use PyOdbc. So this is why I said you needed to have the Odbc driver. And you need to have this, what's called a Dsn connection. Well, the Dsn connection is the easiest way to do it. Okay, so you can see I have Dsn connection equals JData, database supply chain model, trusted connection equal yes. And so that's basically saying use Windows authentication so you don't have a user ID and password.
Okay.
Let me just show you really quickly about this Dsn, because I think if you've never done it before, it can save you a little bit of time. And you're not going to be able to see this, but if I click on the Windows key and then search for data connectors, or data sources, you can see that we have 64-bit Odbc data sources. You can see my screen now. Is that right?
Yeah.
Yeah.
So here's JData right here. I just created JData. And so if you just look at the configuration here, I just named it JData, and you have to give it the server. And so my server is localhost. Okay. Now, one thing that's a little bit tricky, that if you get SQL Server Express, because I'm running a full version of SQL Server here, but if I was running SQL Server Express, that would be the server. So the server would be localhost / SQL Server Express. Okay. But as I said, I'm running the full version, so I don't have that. But if you run SQL Server Express, you will have that. Everything else is just the default. I don't have a default database. I just defaulted everything else. And once I have that set up, then in the Python, I can just say Dsn equal JData, and then tell it the database I want to connect to is supply chain model, and then it will connect to that database. Okay.
Okay.
Grant, does that make sense to you?
Yeah, that makes sense. Are you recording this so we can watch it later?
I am. I'm recording it,
Okay.
and I will put it on YouTube and post a link.
Okay. Okay. Yeah,
I
I
will
understood.
say
what
I've
you
never
said.
done this. I had never done this before myself. I just searched for it on the web. So
Okay.
I know what a DSN and all that stuff is, but it's really kind of straightforward to do. And I am
Okay.
recording it, so I'll put it there. So once I do that, then I have the connector. And then once I have the connector, then it's going to be just like we've interacted with MySQL in class and all that kind of stuff. And so what I do is I just have a replenishment here that basically says I want to fix the replenishment locations. So if customer 1 makes an order, replenish from DC1. If customer 2, replenish from DC2. Customer 3, DC2, and so on. So I've just made a firm, I'm not doing any kind of optimization, right?
Yeah.
Yeah.
So I need to do two things here. I need to specify for the customer, I need to specify the replenishment source, and I need to specify the ship date. So one thing, let me go back to my table here for Jingwei, because I didn't really explain this in detail, is what happens is when a customer places an order, we create a row in this table. We give it an order number that we just keep a running count of. We attach the order date because we know when it's the order. We attach the customer, the material, the quantity, and the due date. So all of these things are put, are created when an order is received.
Yeah. Well,
What's left blank is the planned ship date, the actual ship date, this filled, it's just a Boolean yes, no, whether it's been filled. The source is blank and the arrival date time is blank. So all of these things are blank, okay?
Yeah.
And so when you execute the planning process, so we have, this system runs on a 24-hour clock. And at 8 a.m. every day, we receive all the orders. Okay, so we just look at all the orders at 8 a.m. Doesn't matter when they actually come in. And then at 9 a.m., we run the planning process. And what the planning process does is it says, show me all the orders that are not filled, okay? And then I want to send those orders to my Python script so that it can then set the planned ship date, set the source, okay? So the Python is going to set this and set this for the open orders. Then when I get done with the planning process, I'm going to search the table and say, are there any orders that are unfilled, but that, you know, the planned ship date is now, or, you know, I should ship it? And if so, then actually ship it. So we actually simulate the shipping of the order. And then that we draw a sample time for the lead time and all that. And then so the simulation is going to fill in the ship and the arrival date. Okay.
Okay.
So in my really simple program, I'm basically saying when I get an order for customer one, I want to always ship from DC1, and I want the planned ship date to be the same date that it was ordered. Okay. If I get an order for customer two, I want it to ship from DC2, and I want it to ship on its due date. You know, maybe it's close or something. So basically, I'm using this list to specify by customer the planned ship date and and where I ship it from. Okay, that make sense?
Yeah.
And so I'm doing that with an update query. And so the communication mechanism between Simio and my Python program is the SQL Server database. Okay, so SQL Server database, which you saw, has, so let me go back to my SQL Server database. Here it is. Here's my Python program here. Scroll down here. There we go. There's my open orders. And you can see what happens is when I do update order, set plan ship date equal, source equal, where customer equal, what I'm going to do is I'm just going to read these open orders. And for each open order, I'm going to then apply this list to determine the ship date, the planned ship date, and the source. And then I'm just going to write that back to the database, which is what you see here. Okay? That make sense?
Okay. Yeah.
Okay. So a couple of technology things to make that happen, or that I'm going to show you. I also have a debug flag here equal 1. And so I'm going to show you this with debug equal to 1 so that you can actually see what's going on. But you can see my two comments down, my two statements here. If debug is greater than 0, then I just show everything. I just show the orders that I just dealt with. And I also have this input. And so in Python, what this input function does is it will just not terminate the program. So basically what it's going to say, it's going to pop up a message that says enter to continue, and it'll just stay there until you hit enter because I want to be able to see the screen. Okay?
Okay.
Okay, let's see. Now, how to get this happen from Simio. Okay, how to actually tell Simio, write the data to the database, call the Python script, and when the Python script finishes, go read the values that the Python script wrote. Okay? Yeah. That's the task at hand. To do that in Simio, if you go to my process, you will note if I click on user define, which are user defined steps, right, in Simio, if you compare my list to your list, I've got quite a few more user defined steps because I've defined some user defined steps. The one that I'm going to show you today is called Python. Okay, so I've created a user-defined step that calls the Python program. Okay?
Okay.
And I'm going to show this to you in just a second. I'm just trying to explain what's going on. Okay, so if you look at what's happening in my model, here's where customer orders get created. And so you can see that here's where I do the add row to the customer order table. Here's where you can see that I assign the order number, the customer number, the order material, the order quantity, and the due date to the row. And this just happens, this process happens periodically, just happens over and over and over for each customer based on the values in that demand table. And so all this does is writes data to those tables. Then I have a process order process, which actually does the order processing. And so you can see that this is triggered, this process order is triggered by process order event, okay? And so this is where if you go over to my timers, I go back over to my timers, process order trigger, it happens every 24 hours with a 1 hour offset. So my simulation starts at 8 in the morning, so this gets triggered at 9 o'clock every morning, okay?
Yeah.
And basically what this process does, I'll just read to you what it does, and then we'll go back and explain the details. It updates the inventory levels. So this is what looks in the simulation and says, record all the inventory levels to the database, right? So that the Python script will know what those inventory levels are. Then truncate the the open order table. So this DB query does a query to the SQL Server database and just truncates the open order table. And truncate basically says delete all the records and then reset the counters. Then I'm going to search for open orders, and for each open order, I'm going to write it to the database. So when I search my customer orders for all those orders that are not filled, and I have an infinite number here. Okay, so what's going to happen is it's going to search that customer order table, and it's going to find every record that has the the filled flag equal false. So you're going to get all the open orders. It's going to create a token for each one of those, and then it's going to use DB write to write a record to the open order table. Okay.
Okay.
Then I have this search. Another important part about the search here is that if you look at this token wait action, it says wait until token processing complete. So it's going to remember how a search works in the process is it searches, in this case, a table, and it creates a token for every row of the table that it finds. All of those newly created tokens go this way, and then the original token goes this way. And so the token wait action says, wait till all of the new ones are processed before you let this one continue. And so what that guarantees is that when the original token leaves the search, all of the new orders will be written to the external database. Okay?
Yeah.
Then I'm going to call the Python script. And you can see I have a breakpoint here because I'm going to show you some of this. When I come back from the Python script, then what I want to do is do the exact same search that I did here. I want to search for all of the orders that haven't been filled. Okay? And then for each one of those, I'm going to use the DB read step to say, hey, go read the planned ship date and the source. Okay? Because that's what the Python's deciding, right? In my Python script here, for customer 1, DC1 and order date, for customer 2, DC2, due date, and so on. So those things are being decided in the Python program. So I'm going to read them from the database. Okay?
Okay.
And I'll explain all this stuff later. Just forget this stuff for now. So when I come out of the search, I'm going to have all those values. So now, when I exit this search, I have that same token wait action. When my original token exits, now I have written all the open order values to the database. I've called the Python script. I've read from the database all of the decisions that the Python script made. That's where I am right here. Okay. So now, as I said, I'm going to search and say, hey, give me the orders who haven't been filled yet, whose planned ship date is less than or equal to time now. In other words, has their planned ship date occurred? It's either now or it's in the past, okay? For each one of those, I'm going to say, okay, search for the replenishment source that you're given, right? So you're given the replenishment source, but I need that row reference, so I search its table, and then I execute try to fill customer demand. And so fill customer demand says, okay, I'm first going to notify, then I'm going to consume the inventory from the source. I'm going to say the order has been filled, And then I'm going to create an entity, and you'll see this when I show you the model. I'm just going to create an entity and then send it to the customer. Okay.
Okay.
So is the main flow of what we're trying to do? Does that make sense?
Yeah.
Okay, so let me show you it running now, and then I'll come back and talk about some of the technical details, okay? So I have these breakpoints set. So what's going to happen is I'm going to execute it, and it's going to break right here on the call Python. Okay, so what will have happened when I click run is our first set of customer orders have come in, okay? And so when our first set of customer orders come in and I get to processing order, I update the inventory level. So this will have happened. I will have truncated the open order table on the database. I will have then searched for it and written all of the new orders that I have to the database. Okay, that's what will have happened before I get to here. So let me just run that. Actually, yeah, I can do the run. Okay, so now you see we're at that breakpoint. Okay, you see the breakpoint here?
Yeah.
You can see my inventory levels here. So first thing I'm going to do is I'm going to go over to data, and here's my customer orders, and you can see that I have my first set of customer orders for my 5 customers that all came in at 8 o'clock on 8 o'clock on January 1st, 2021. Okay.
Okay, so I have a question. So
Okay.
if you set a breakpoint, the process will automatically suspend in that breakpoint.
It suspends before executing that point. That's what I did right here.
Okay.
And so right now, the simulation is sitting right here at this breakpoint, waiting for me to say go.
Okay.
Okay. So data again, we've just written all the customer orders. Note again that none of them are filled. None of them have planned ship dates. None of them have sources.
Yeah.
Okay. Now, if I go to my SQL Server and say, let's look at these. So let's just select all of the records from open orders. So I execute those, and now you can see I have exactly what I had in the Simio, in that I have my 5 orders. None of them have a planned ship date, and none of them have source. Okay.
Okay.
All right. So we are kind of halfway there. So let me go back to my Simio and go to my process, and I am sitting right here. So, excuse me. When I click step, I want to run in step mode, and I just wanted to do the call Python. Okay. So I'm going to go to facility, and then I'm going to go to run, and I'm just going to click step right here. And what you can't see off screen, which I will drag to on screen, is this is my Python executing. And so you can see, since I had that debug flag set to 1, it printed out everything that it uploaded. Or, I'm sorry, that it retrieved from the database and then made decisions and wrote back. And then I've got this enter to continue, so it's waiting for me to hit enter. Okay.
Yeah.
Note, if I go back to my SQL Server and I update again, now all of my planned ship dates have been set, and all of my sources have been set according to those the fixed ones that I have in the Python script. Okay.
Yeah.
Does it make sense?
Yeah.
Okay, so let me go back to my Simio. And hit enter to continue. Python script goes away, and now we have stepped. So where we are right now is I'm right here, because I didn't say run, I just said step, and so it executed this code right here, and now it's sitting right here waiting for me. Okay. Now when I hit run, it's going to run, and now you can see I've a couple of customer orders that are going to their customers. My trace is going, and now here I am at the breakpoint again. So what happened is we have our second set of customer orders, because here we are at time 25. So 1 day has elapsed. We've got a new set of customer orders that came in. And if I go back here, here are the new orders. They don't have a planned ship date. These are the 2 that just came in. Okay, and now I'm sitting back and waiting for the Python. So if I click step here, then we just executed the Python script again. Right, and so here are all the open orders, or the orders that haven't been filled. I hit enter to continue. Now I think we're going to, I hit step mode, so let's just run, and now we're shipping some more orders. Okay, does general flow of it make sense to you now? I know all the details aren't going to make sense because I'm hitting you with a lot of stuff here. I just want to make sure you have a feel for the general flow of what's going on.
Yeah, so when you reach the breakpoint and then after you running the Python code and you click the step, means you just finish the next step and then you click run again, right?
Yeah, so what I showed you was I ran to the breakpoint, which is right here, and then I clicked step, and so it executed this one step, right?
Okay, yeah.
Then it stopped here after executing the step.
Okay.
Then I clicked run. So when I clicked
Okay.
run, it did all of these things, and it went all the way back around to the next time it hit the breakpoint.
Okay, that makes sense.
Okay?
Yeah.
All right, Grant, any questions from you till we jump into some details of how this all works?
No, I think I understand what you're talking about. It's basically just the implementation of what we discussed in words from last week.
Yep, that's right.
Okay.
Okay, so let's look at some of these details. So DB query, DB write, and DB read are all come with the standard install of Simio. Okay, so if you look in your Simio installation under user defined, you will see those steps. Okay, again, DB query, DB write, DB read. Okay, now what you might not know, I don't know whether you know this or not, but if I go look at this, from the standard Simio install, if I go to users, public, documents, Simio, examples, user extensions, there are all of those steps that you see in user defined are right here. So you have the actual code for all of those steps. That's why they call them user defined. So again, if you look at DB read write, you can see here's the C# code for that step.
Yeah.
Okay. That's all there. So I created a new step called call Python. Okay. And so if you look at users, JSmith, documents, Simio user extensions, right? So here's the directory, users, JSmith, documents, Simio user extension. You can see these DLLs, call Python. I did some manipulation of DB read write, so I made my own version of DB read write. MongoDB DLL, Mongo Bison XML, and SC table. And so this call Python, the SC tables DLL, that's where this comes from and this comes from, because what those are custom steps. Okay?
Yeah.
Now, here is Visual Studio. And so here is this is the call Python project. And all of this is also on that Teams folder, right? So you have all of the code for this custom step, okay? Now, at a minimum, what you need to do to make this work is you need to go to that, let's see, I have it right here. Go to ASIM general, sample model, supply chain. Right here, this call Python script, okay? And from within here, in object debug, there is this DLL, call Python DLL. You need to copy that into your user documents Simio extensions folder.
Okay.
So when you copy that DLL into that users, your user ID, documents, Simio user extensions, that will make it available to you. That will make that step when you restart Simio, the step that this code creates will be in the user defined. Okay.
Okay.
But you have all the code. If you want to do anything different or change anything, you have all, and you know C#, you have all the code to do that. Okay.
Okay.
That's why I provided it. One little quick note here that I'm going to show you here in just a second. There's one little line here that you might want to change at some point. That's create no window equal false. And so because I have this set, that's why when it executes call Python, it pops open the command window. If I had this set to true, it wouldn't pop open the command window. Okay.
Okay.
So you want to have the command window to pop open while you're doing debugging, but when you're actually running it, you probably don't, because it's an annoying, it gives you an annoying pop up the command window and then blink. You know, it pops it up, the Python executes, you know, and then it goes away. And so it gives you an annoying blink. You'll see what I'm talking about if you run it. In the Python script, before I forget, there's also a little note here on the debug flag right here, that if you have this set to 1, then you need to make sure that this is also set to false. Otherwise, it's not going to open the window, but Python is still going to be waiting for you to hit enter, and so you won't be able to do anything. So when you have this set to true, you need to make sure this is set to 0. And then what happens is, if this is set to true in the C#, and this is set to 0 here, the Python gets called and you never see it. Right? It gets called, it reads the database, it makes a decision, it writes to the database, it terminates, and you never see it.
Yeah.
Okay, but for debugging, you need it. You need that. You want to have that. Okay?
Yeah.
Does it make sense? Grant, you with me?
Yes, I am with you.
Okay. So that's there. As I said, you probably won't need to do much with this. It's cool. You can look at it if you want, and make changes if you want, if you know C#. As a kind of a side note, you could also do everything here, right? So the reason that I write to the database, call a Python script, and then read from the database is because I'm more comfortable with Python than C#. I could also make a custom step where I do all of the stuff here. So inside the C#, I could query the database, formulate the optimization, call Garobi or Cplex or whoever, right back to the database. I don't have to call Python. Okay, just I'm not that comfortable writing in C#, so I didn't want to do it in C#. Okay, so the DB query, again, what it does is it just sends a query to the database, and you can see my query here is truncate table open order, so that just truncates the order. This uses a DB Connect element. So I got to go to definitions, and you can see I have a DB Connect element right here. You guys see that?
Yeah.
And what the DB Connect element is says what's the server and what's the model. I'm sorry, what's the database? Okay.
Okay.
So as a note right here, if you're running SQL Server Express, just like I showed you with the Odbc driver, it's going to be server equal localhost / SQL Express. That's what the database name is. And you can see that if you look at Management Console, when you look right here, it will have that. It will have the name of your computer / SQL Express.
Okay.
Okay, so that's what needs to go here instead of just localhost. It needs to be / SQL Express. And then again, the database equals supply chain, and then integrated security equal true, so you don't have to use that. It uses the Windows authentication. Okay, so this is my database connector, and so that's used for DB query, it's used for DB write, and it's used for DB read. Okay, so for DB write, what you do is you say, okay, here's the table, open orders, and then it has a repeat group. And for each repeat group element, you give it the column in the table and you give it the expression from Simio. So I'm saying the column in my table is order number. The Simio expression is customer orders.order number. Then customer name, material name, quantity. So right, it's just taking the values from the table and writing them to the database. Okay?
Okay.
All right, so we write to the database and call Python. Call Python is really simple. You give it 2 things. You tell it what's the Python executable location. So I'm using Anaconda Python, so it's C:\anaconda3 / python.exe. That's the Python executable. And then you give it the script name, supplychain.py. And so all this is going to do is it's going to stop the model. It's going to execute this program, which is Python interpreter. It's going to pass it this parameter, which is the script. So Python interpreter will execute that script and do the reading and decision making and writing that I showed you before. Okay? Grant, you with me?
Yeah, maybe my brain like spaced out. Where where does the script have to be in order for Simio to recognize and to call it correctly?
That's a good question. So the script needs to, you either need to give it a fully qualified path name,
Okay.
or the script needs to exist in the same directory that the model is in.
That the model is in. Okay.
Yeah, so models
Okay.
is in a directory, and it's
Yeah.
going to look there for the
Okay.
for this. That's where it's actually executing. Okay.
Yeah.
All right. So then remember what we're going to do is we're going to search for all of the orders that haven't been filled, and so we're going to have one token for each one of the unfilled orders. And so I'm going to then read my values. You can see I'm reading open orders, and I'm saying read plan ship date, and store it in the state customer orders.plan ship date. So basically it's saying reach into the database, grab plan ship date, and store that in the table with the column plan ship date. Okay? Does that make sense?
Yeah.
Grant? The next one is a little bit more involved. That's why I want to make sure this one makes sense.
So it goes into the database and does it like paste across all column, like the whole column gets stored?
No.
Okay.
So remember that when we come out of the search,
Yeah.
the token will have a row reference to the table, right?
And
so
we're currently on the found branch.
yeah, we're on the found button.
Yeah. Oh, okay. So it'll get stored in the value associated with each of the tokens.
Correct.
Okay.
Okay. So
yeah.
Now the second one is a little more complicated. So let me close this and then let me go back to here. So remember what we're doing is when we search this table, it's giving us all of the ones with filled equal false or not checked here. So we're going to get this one, we'll get this one, and we'll get this one. Okay. And so let's say we're on this one. What happens is the token that's associated with this one is going to know customer 2. It's going to know the order. Well, it's going to know everything in the row, right? And so when it reads it from the database, here's where it stores plan ship date. It just says, hey, store what's returned from the database in plan ship date. Okay?
Right. Because it's going to do is it going to do the DB read for every token?
Yeah.
Okay.
And we have a where condition. We are using the order number for the where condition. So it's going to be select where where order num equal whatever. And so we will do it each one individually.
Okay.
Okay. So it does this one. And the other piece of information it's looking for is source, right? So you're getting 2 things for each record. We're getting plan ship date and source. Plan ship date, we just read and wrote. Source is a little more complicated because source is an object reference. It's not just a string, it's an object reference because this is a reference back to my distribution center object. Okay? Does that make sense? If I look here, it's an object, it's a object reference variable.
Yeah.
Okay.
So this causes some issues.
This causes a little bit of grief because we can't just do what we did for this one. What we did for the plan ship date is we basically just said, hey, read it from that column in SQL Server table and store it here. Okay, but we can't do that with the object reference state. So what I do instead is I read the value and I store it to a string state, right? So this process right here, this process uses a custom token called miscellaneous token or mis token. So if I go back over to my tokens, here's mis token, and I have this string state 1. It's just a string state variable associated with the token.
Okay. So this is like a temporary token.
Yeah, well, it's a temporary string state associated with the token.
Okay.
Okay.
And it's for the whole process or just this step?
Well, it's for the whole process. So every token that's in this process is going to have its own string state 1.
Okay. Okay.
Okay. That's why I use the token state rather than a global state, because I could have 20 different tokens in this process at the same time.
Okay. And you stored the string value for the source from the database into this. Okay.
Into this
okay.
token.
Okay.
Okay. So now what I have to do is I have to be able to figure out based on this string, which is either going to be DC1, DC2, or DC3, I need to figure out the object reference for it,
Ooh,
right? Because it's a
Yeah.
string DC1, but I need to have the object reference DC1. Okay,
gotcha.
is that
Yes.
clear,
Yeah.
Jingwei, what the intent?
Yeah, I know that.
Okay, so here's how I do it. So in my table, in my object table, notice that this is a key column. Name is a key column right here. Okay. So I use the row for key function, which says take a table, objects, a column, name, which is a key table, key column, and use the row for key function based on the string state. So let's say that the string state is equal to DC1. This is going to say objects, name, row for key, DC1. Okay? So what it's going to do is it's going to look in this table and say, hey, what row is DC1 on? And it's going to say it's row 5. Okay?
So it's gonna be it's gonna be an integer after.
It's going to
this
be 5.
operation.
It's going to be 1,
Okay.
2, 3. It's going to be either 1 through 12, or if it doesn't find 1, it's going to return 0.
Okay.
Okay? So it says, so in the case, if it's DC1, it's going to return a 5 to me. Okay? So now that I have that reference, I can first check and say, is it greater than 0? In other words, did I find it? And if so, now I can make the assignment. My customer order.source is objects row.name. So if think about this, if it's row 5 for DC1, if I go over here and say objects row 5 name, that gives me DC1, the object reference. Okay, so what this does is it basically says, okay, read the object reference into a string state, then use that row for key function to find the index in the objects table of that key, then verify that I found something, and then if so, now I have the object I have the object reference. Okay?
Yeah.
Grant?
Yeah, that makes sense.
Okay, so again, I have this token wait action here is wait until new token process complete. So basically it's going to search for all of the unfilled orders. It's going to execute my query to update the planned ship date in source fields. Then my found token is going to come out. Then I'm going to search everything for orders that have not been filled and for which the planned ship date has already occurred. And for each of those, I'm going to go find the replenishment source that's specified by the table. And then I'm going to execute this function to actually fill the order. Okay?
Yeah.
So now let me go in my model here. I'm going to do a couple of things here. I'm going to set my debug equal to 0. So the wait's not there anymore. I'm going to save that. So it's not going to wait anymore. Then I'm going to go in here and I'm going to take my breakpoint out and go here and run the model. And so what you can't see, because it's on my other monitor, is every time it executes Python, I just get this little blink where the command prompt opens up, it executes the Python script, and then it disappears.
I have a question.
Okay.
So if you delete the breakpoint, so will when we execute the Python code, is the Simio model suspend, or it will keep running?
It's suspended. So it waits. It sits at that step. So, you know, if I pause the model, for example, here, and go look at the process, when a token goes in to call Python, okay,
Yeah.
the model stops. Simulation time doesn't advance. It just waits here for the Python to come back.
Okay, that's great.
Okay.
Yeah.
And so if I go fast forward, I don't remember how long I run. And over here on my other monitor, it just keeps blinking on and off every time that Simio gets called. And then I go back and stop, and I go back and look at my data, customer orders. You can see now for all the orders except the ones that happen, towards the end of the run, I have the actual ship date and the actual arrival date to the customer. Okay,
Yeah.
Grant, make sense?
Yeah, it makes sense. So basically by the end of that process, it's the same as so the model I'm currently working on just kind of quickly makes those assignments.
Yeah, so the model that I
no.
gave you that's working on right in here,
Yeah,
you basically right here,
it doesn't even do that. It's
it's
very
it's
simple.
basically just searches for open orders and then searches for a replenishment source and fills the order.
Yeah, and this one replaces that action with the database in the Python.
Yes.
Okay, and so at the end of the process, we have a full customer order table.
Correct.
Okay, yeah, I'm with you.
Okay, so one thing I didn't show you is this update inventory levels. Okay, so if you scroll down to the bottom, here that is, where what I'm doing is I'm searching the inventory table, and then I'm assigning the quantity in stock to a state variable called inventory position. Okay, so go look at my tables, inventories. Where is it? My inventories. Here's my inventory position. Because it's an output column, that means I can write to it. Okay, and so I'm assigning that value right here. And then I'm doing a DB execute where I use an update query to update the corresponding row in the SQL Server table. Okay, so if I go back to my SQL Server here and look at my inventory, let me just sort it. So if I just right click here, it'll build me a little query to select the top 1,000 rows. So let's do that. And there they are. So here are the inventories, and here was the last inventory position that was written by that fill step. Okay. Grant, make sense?
Yes, I did have a question about the step in Simio.
Okay.
Not the SQL Server. I understand that part. What is in the SQL statement the use of @2 and @1?
That's a good question. So my SQL statement, update inventory, set inventory position equal @2, where name equal @1. And then the items are, where's my, right here, right? So here's item 1 and here's item 2.
Okay, so it will replace the @2 with inventories.inventory position.
Yep.
And then @1 with inventories.name.name.
Yep.
And why is there 2 names? Is that because name is an object reference?
Yeah, name is an object reference in the
Okay.
inventory table. And so I don't want the object reference. I want the name of that object reference. In other words, I want the string.
Okay.
Okay.
Makes sense. Yes, and this DB execute, is this what's packaged within Simio, or is it one that you've changed?
I made a change to it, but it's the standard one will work.
Okay, because I noticed it. Yeah, okay, that sounds good. I just noticed you have multiple in your user defined, so I
did because I made a couple changes while I was doing some debugging.
Okay.
Okay.
Yeah.
So one quick comment here, you might not have noticed, all Simio steps have something called an exclusion expression. Okay.
Mhm.
Yeah.
Basically what that means is if this expression evaluates to true, don't do this step. And so if you look at my database things, I've got right here, I've got exclude database for my exclusion expressions. And so what those are is if you go to my definition, properties, exclude database, exclude debug, temp exclude, these are all set to true by default. So if I go back to my facility, here's where I set those. Right, so exclude database false, exclude debug false, temp exclude false. If I set these to true, then all of these steps will get skipped. These will all get skipped.
So this is the same with the other exclusion expression that will be evaluated at the start of the simulation, right?
And right, it gets evaluated at the start of the run.
Okay. So it means each run it will evaluate it for each each time when we run this step, it will evaluate it.
Yeah. But because I have it set to properties, I can't change that during the run.
Oh, okay, yeah, that makes sense.
Okay. So this is just here so that if I want to turn off the database read and writes to do some kind of debugging or checking or whatever, I don't have to delete the step, right? I just set this
Yeah.
exclusion equal to true, and it won't execute it. All right.
Yeah.
And so this is
question-
common.
oh,
So
sorry.
this is a really common thing in a lot of models, at least that I do, where you have exclude debug. So if you look at a lot of the notifies and all that, exclude debug. So if I want to turn debugging on, I just set that value equal to false, and all of these notifies happen. If I set that equal to true, then none of the notifies happen, and so it doesn't fill up my my trace.
Yeah.
Okay.
Yeah, I
Grant,
like that.
You have a question for me, Grant?
Yes. Well, one, I like that debug thing with the notify step. That's nice.
Yep.
The inventory levels, they're in the state variable column, and they're only updated once per day alongside the other process, correct? Like, so they're a snapshot
Yes.
at like 8 a.m. in the model. Is that correct?
9 a.m. because that's
9
when
a.m. Okay.
Right. So
Okay.
that they get updated here. In your
Okay.
model, though, if you want to update them, you can just execute this process at any time you want, and it'll update them. It just
Right.
I just happen to only do
okay.
it when I write to the database because that's all I care about.
Okay.
I think I also do it on run initialize, truncate orders,
You do. It's
truncate
that
open
executes
orders, and
it.
execute. So on run initialize, I do an initial update.
Okay.
Okay.
Yeah.
Okay. So finally, wrapping up. So what my Python script does, again, is a very, very simplistic thing, right? It just says anything from customer 1, fulfill here, and set the planned ship date equal to the order date. Customer 2, so on, right? Obviously, that's not what we want to do, right? Obviously, what we want to do is make a good decision of how to do it, okay? So one of the other things I have in the, let's see where this is. Hold on, let me go make sure I've given this to you. Let me go look here, make sure this is here. Let's see, go to AUSIM, general, sample model, supply chain. Yeah, there's this SQL Server Scripts, SQL Server Script folder. And what that includes is a bunch of SQL scripts and a project and a solution that are associated with the Server Management Studio. So this is a solution over here, okay? So it's like a project in any other IDE, okay? So a couple of scripts that I gave you that you'll note are valid inventories by open order, okay? So here that is. So you can see this is just a little bit more complex of a query where I join together the open orders, the replenishment sources, the inventories, and the transportation lanes tables. And when you execute this, it basically says, okay, here are my open order, 64, 57, 63, 64. And for each order, give me all of the replenishment options, give me the order quantity, give me the inventory associated with that replenishment option, give me the priority, give me the inventory position at that inventory, and give me the expected travel time along the corresponding transportation lane. Okay, so if you just tell me an order, basically what this does is it says, okay, in order to make the decision you want to make, I need to look at where can I replenish this from, which comes from replenishment sources table. What's the inventory at that replenishment source, which is in the inventories table, okay? And if I choose to do it, what's the expected lead time? And that's in the transportation lane table. So what this query does is it does this 4-table join to give you that information. So in the Python script, and there's one more also, there's one for a specific order. So you give me an order, right? What's the order here? Where inventory? Oh, for specific order. There it is. Yeah, for order 6, for example, it gives me that essentially that same thing. I think 6 is already filled. Yeah, 6 is already filled. What were some open ones? 64. So let's go over here and change this one to 64. And execute this query. And it says, okay, to fill order 64, you got 3 options, right? And here's the inventory position and the expected travel time and all that for my 3 options. Okay?
Yeah.
So the reason I did this is basically just to experiment, because I'm going to have a query much like this inside the Python so that I can grab all the information. I'm then going to have an optimization model already designed. And so this is going to be, you know, the various coefficients and all that for the objective function, and the constraints for my optimization are going to come from a query much like this. Okay.
Okay. Okay.
And all of this is here. If you guys want to look at it, the scripts that I put together and everything, that's all there. Okay.
Yeah.
Grant, you good?
Yeah, it's just a lot of information that I need to look back over, but I understand the broad, objectives that you're doing, that kind of thing.
Yeah, and just so you guys are aware, I didn't just sit down and do this, over the span of an hour or so. I've spent a couple of weeks on this, because I'd never done a custom step before. I'd never used SQL Server before. I didn't know what this management studio thing was. So, when I started this a couple of weeks ago, I was probably in the same state that you're in right now.
Yeah, that's really useful. I think that's exactly what I want to figure out how to do.
Yeah.
Yeah.
Okay. So I'm gonna stop the recording now.